For this calculus problem of the day, we're given this function here, and we're asked to find the tangent line to this function at the given point. And we're given this formula here for the slope of that tangent line. Sometimes we see this formula written in this way, with an x in the formula instead of an a. But since we're given a point in this problem, we're given a specific value for x, we're calling that a. So we're going to use this formula here. Either way, whether we've used these words in this class or not, whenever we're finding the slope of a tangent line of a function, we're finding a derivative of a function. All right, there's a lot more of that to come. But because we're given this point 1/1/5, we know that we're going to have an a value of 1. So the slope of our tangent line with a equals 1 substituted in looks like this. So we need to start this problem by finding f of 1 plus h. That just means we're going to take this function up here and we're going to replace x in that function with 1 plus h. Okay, f of 1 is going to be very similar. We're just going to replace x in this function with a 1. Now we need to do a little bit of simplification. If we distribute the 3 through the parentheses, this term here ends up turning into 1/5 plus 3h. This term here just turns into a 1/5. And we have a lot of fractions going on here. If we're going to simplify this, unfortunately the only way we're going to be able to do this is to combine these two fractions using a common denominator. That would mean multiplying this fraction by 5/5 and multiplying this fraction by 5 plus 3h over 5 plus 3h. If we do that, our first fraction ends up with a numerator of 5 and a denominator of 5 times 5 plus 3h. Our second fraction over here ends up with a numerator of 5 plus 3h and a denominator of 5 times 5 plus 3h. Now the two fractions in the numerator have the same denominator, so we can combine them. Keep in mind that this negative sign here is on this entire term, so if we're going to combine these two fractions, we need to make sure that we keep that negative sign on this entire term. All right, let's keep moving here. We're going to end up with 5 minus 5 canceling in the numerator, so we'll just have a negative 3h in that numerator. Now this factor of h in the numerator and this factor of h in the denominator can cancel. If you want just a couple seconds of clarity as to why, what we really have here are two fractions, a fraction on top and a fraction on bottom. We can call this h on bottom h over 1. Now that we're dividing fractions, we can do the whole copy dot flip thing, where we copy the fraction on top and flip over the fraction on bottom. And now you can see a little bit more clearly that these two h's will in fact cancel. So you can do that the long way or the short way, but either way you look at it, you end up with a negative 3 on top and a 5/5 plus 3h on the bottom. Now maybe it would be good to point out that we've done all of this algebra so far, because in every one of these terms from the very beginning, if we plugged h equals 0 into this expression, we would end up getting 0/0 in indeterminate form. So we did all of this algebra just so we could cancel these h's down here, and now when we plug h equals 0 into this expression, we no longer get an indeterminate form. We simply get a slope with a negative 3 on top and a 5 times 5 on the bottom, so that's negative 3/25 for the slope of our tangent line. Now let me zoom out here so we can see the original problem again. We were asked to find the slope of the tangent line, which we just did, but we were also asked to find the equation of our tangent line. To find the equation of a tangent line, you might recall a couple of forms for lines. One is called slope-intercept form, the other is called point-slope form. And we can use either formula to find the equation of our tangent line. I'll just use point-slope form. What we do here is we take the point that we're given that had a y value of 1/5 and an x value of 1, and we plug that point in for x1, y1. And we take the slope of the line that we found earlier, plug all of that stuff in, and we get this result. Now most of the time we want the equations of our lines to be written in slope-intercept form, so I'm going to distribute the negative 3/25 through the parentheses. I'm going to add 1/5 to both sides, and I'll go ahead and combine these two fractions with the common denominator by multiplying this term by 5/5. That gives us 3/25 plus 5/25, that's 8/25. And we now have the final answer for the equation of our tangent line. Now you could graph this original function and you could graph this tangent line. I just did it on my old calculator emulator here. I had to play with the window quite a bit, but you can see that our function f of x is right here, and the tangent line that we just found just touches that function once at the point 1/1/5 right here. So this checks out. It looks like we did this problem correctly. Okay, good job. I will see you in the next calculus problem of the day.